Good afternoon, everyone. Thank you for joining today's webinar, Three Scenarios When Upgrading Your Data Warehouse to the Cloud. My name is Ali Diallo, and I will be the host for today's session. Please note that all lines have been placed on mute to prevent any background noise. This session is being recorded, and the link to the webinar will be shared afterwards. If you would like to ask a question, you may do so via the chat feature in your GoToWebinar dashboard. If time allows, we will review those questions at the end of the session. All questions will be entered. I will now turn the session over to our presenter, Michael Sims, Vice President of Strategy and Change. Over to you, Mike.
Thanks, Ali. All right, everybody, welcome to Three Scenarios When Upgrading Your Data Warehouse to the Cloud. As Ali said, my name is Mike Sims. I'm the Vice President of Strategy and Change. There's all of my information. If you would like to link in, that's probably the best way to get me online. I very rarely do Twitter. I should probably do more. My phone numbers are there as well. So today's agenda, we're going to have an introduction. We're going to talk about the different Azure services and how I like to group them and think about them as a whole, and how we at Columbus actually group them up as well. Talk about cloud architecture in a scenario for larger data warehouses, but there's some substitutability that we've used with other clients, and we can discuss those things as well. Then we're going to get into actually why you should migrate, what that upgrade process is from on-prem to the cloud, some recommendations and considerations, and a couple of use cases, and questions. So introduction is, there's a lot of content here, so I might as well just dig right into it. Data warehouses have supported business decision-making for years. Many companies today have long had analytical data warehouses in place in their data centers to support decision-making in different parts of their business. Sales, marketing, and finance departments in particular are heavy users of such systems, producing standard reports and dashboards. They also employ business analysts to perform ad hoc query and analysis on data in data marts designed for multidimensional analysis using self-service business intelligence tools. However, while data warehouses support some key aspects of decision-making, the shift to digital technologies over the last several years has seen changes happening around the data warehouse that are having major impact on traditional analytical systems. This includes source transaction processing systems such as CRM, HR, and ERP systems moving to the cloud. Often this is done to consolidate similar systems, to scale and enable mobile self-service access to transaction processing systems by customers, something like mobile banking, partners, suppliers, and employees. This has resulted in data warehouses now needing to capture data from cloud SaaS applications. In addition, new data has emerged that businesses are now capturing, such as online clickstream, social network data, Internet of Things, sensor data, open government data, weather data, image, audio, and video data. However, very little of this type of data has made it into the data warehouse on-prem. In fact, it is often processed and analyzed separately at scale in the cloud, while data scientists use it to build machine learning, predictive, and prescriptive analytics. In addition, with so many new data and analytics technologies now appearing on the cloud first, the attraction of moving analytical workloads to the cloud to quickly take advantage of these technologies is becoming more and more compelling. Given this backdrop, it is not surprising that many companies are now considering moving their data warehouses to the cloud as part of a data warehouse modernization exercise. Today, many organizations are migrating their legacy data warehouse solutions to the cloud to gain the benefits of an end-to-end analytics platform that provides high availability, security, speed, scalability, cost savings, and industry-leading performance for enterprise data warehousing workloads. As technologies evolve, the benefits of having cloud-based data warehouse solution far outweigh its on-premise counterparts. cloud solutions such as Azure Synapse not only provide industry-leading performance for running enterprise data warehousing workloads in the cloud, it is an end-to-end analytics platform that brings data ingestion, data warehousing, and big data analytics into a single service. With its scalability and separate compute and storage architecture, Azure Synapse can be scaled instantly in ways not possible with legacy systems such as Teradata, Netezza, or Exadata. For smaller enterprises, solutions using Azure Data Factory, Azure Databricks, Azure SQL Server, and Azure Data Lake provide enterprise-class scalability and performance at an economical cost. So at a glance, these are the Azure platform services. And if you look across the top here, the common practice for any data platform includes ingestion, storage, processing, and presentation. And you can see underneath each of the column headings there, for instance, starting with computing, we have Azure Virtual Machines, Azure Web App, and Azure Function. You get into things like ingestion, and you have components such as Kafka, IoT Hub, Azure Data Factory, Event Hub, and Azure Synapse. You have a variety of storage mechanisms. You can use an Azure Managed SQL Server, Azure Data Lake, Azure Synapse, Cosmos DB, Azure SQL, or Azure Blob Store. And with processing, you have Azure Streaming Analytics if you need real-time analytics off of your systems, Azure Databricks, Azure SQL, and Azure Synapse. And finally, with presentation, you have Azure Analysis Services for tabular models in the cloud, Power BI, which gives you a lot of flexibility along with ETL built right into it, Azure SQL Server, and Azure Synapse, which includes the orchestration of Azure Data Factory as well as the presentation layer of Power BI. If you look at the Azure ingestion services at a little bit more depth, you can see that you have two different constructs here, ETL and ELT. With ETL, which is the traditional method, especially on-prem, you would extract, transform, and load your data. With the ELT methodology, you extract and load your data, but then you transform it in the actual processing layer already in the cloud. I'm not going to go through all of these bullet points. What I would like to do is highlight two of these, which is Azure Synapse and Azure Data Factory. With Azure Synapse Studio, we've been pulling in a lot of data for larger enterprises, and that enables us to do all of our orchestration and ingestion within that one spot, as well as a very SQL Management Studio feel to it. So it gives us a very comfortable migration and upskill from an on-prem to our cloud data warehousing counterpart. With Azure Data Factory, if you're comfortable with a tool such as SSIS, you will very rapidly take to Azure Data Factory. It is a cloud scale ingestion and transform pipeline capability, and it has built-in monitoring and management features, so it allows you to actually track and see how long particular pipelines are taking to run, so that you can troubleshoot if necessary. Storage services, again, I'm not going to read the slide for you, but there are a couple I would like to highlight. And the first one I would like to highlight is Azure Data Lake. A lot of the buzz, especially in the Microsoft community as of late, has been with Azure Data Lake. And that has to do with the fact that everything is pretty much congregating there from their ERP systems and for a lot of other analytical systems. Plus the fact that you have capabilities such as Azure Databricks and Azure Data Factory to read in and read out of those systems, as well as Power BI capabilities right into the data lake. The other attractive factor with Azure Data Lake is that for a terabyte of data, you're looking at a very reasonable $100 or less. With Azure SQL Server, think of that as SQL Server Enterprise in the cloud. It does not have every single feature that on-prem SQL Server has, but it has most of them, including compression and those types of features. And it is really suitable for data capacities of up to 1 to 2 terabytes. Once you get past that, you'll want to look at something like an Azure Synapse or Data Lake. For the data processing services, the one I'd like to highlight here is Azure Databricks. There are a number of different ways that you can use Databricks. I've seen tons of different use cases for them. The nice thing about Databricks is it uses Apache Spark clusters to process large volumes of data, and you can spin those up and spin them down as needed, so that you're getting charged by usage, not just to have the thing running. It helps developers and data scientists to collaborate, and it also supports advanced analytics libraries to implement complex algorithms. Again, Synapse shows up here for processing because, again, it's an all-in-one platform. It does support SQL queries, stored procedures to process data, and it does have Apache Spark as a limited runtime feature, in its interface. One cautionary tale here with Azure Synapse is it does take a little bit of time for compared to for smaller data sets compared to something like SQL Server. So if you have something that is less than, say, half a terabyte or a terabyte, you might want to consider a different architecture. Presentation services. We have a couple of things that I would again like to highlight here. Azure Analysis Services. This is the Azure equivalent of the on-prem analysis services, which allowed us to build multidimensional and tabular models. One thing to take note of, unless it's just recently changed, Azure Analysis Services only supports tabular models. So if you do have multidimensional models, those would have to be refactored into tabular models if you move them to the cloud. One other thing to note is that you're going to have to allow for cache sizing in Azure Analysis Services based on the size of the data that you're going to process through analysis services. So as you're going through and costing these things out, that would be one thing to take into account. If you need any help with the pricing or any of those types of things, please reach out. We'd be glad to help you with that. Power BI, if you haven't already worked with it, it is a very quick adopting tool as far as learning how to build reports and dashboards. There are several different versions of it. There's Power BI Pro, Standard. There's a couple of other ones that are more for enterprise class. So you need to find the right solution that fits your particular organization. If your organization is large enough, you can buy Power BI so that the entire node is dedicated for your organization. And there's usually a break-even point. There's a costing calculator online. The break-even point is around 500 or so users of Power BI. One of the nice things that Power BI really does is it allows you to share reports across your organization. You can then modify those reports to your liking using the same data set and just tweaking it to your particular needs and desires for what you're doing in your job. Okay. So I'm going to go through a couple of quick use cases here. This first use case is pretty simple. We had a D365 customer and an Excel customer, or I'm sorry, the same customer had D365 and Excel. They were putting data in, and they needed to get that data presented up through Power BI. So they used a Power BI data flow to pull data directly from D365 and Excel. And what they then did was they used the common data service and data models to build those out into Power BI. They built some analytical reports such as sales trend, periodic comparison, sales territory, and top and bottom performer. They also built some financial reports such as a balance sheet and an aging. And keep in mind, though, that with this particular approach, you do have a limitation of data of up to a gigabyte. This next one is a company that we're working with currently and hoping to get into the next phase of their product or of this project. They're a manufacturing industry that has sensors throughout their entire organization, throughout their entire production line, I should say. And this is really the only way that they can get the information that they need, because this is a glass manufacturer and the readings that they're getting are off of basically molten material, so there's no way to get information, by getting humans involved directly. And so what they're trying to do is determine what actually impacts the quality of their product, and the primary quality measure is breakage. So if you get a bushing level break, it was taking up to 2 to 3 weeks to identify that A, it was breaking, and then B, what was actually happening that might have contributed to the breaking that was occurring in the manufacturing process. The goal was to get this down to a couple of days or less in order to be able to make the engineering adjustments necessary to try to mitigate those quality issues and get back on track. The next step in the problem statement there is if we were able to predict those future breaks. So we're building or designing a couple of machine learning models to see what we can determine from interactions of the different chemical compositions, the pressures, heat, and other factors in the engineering process. The solution features were that we had several different data sources, some of them coming from web apps. We had an SFTP where we were pulling data that was coming off of an IoT system called Wonderware, where it was getting captured into files that we would ingest. Then we had the actual data processing, which would store in an Azure data lake. We prepared that data through Azure Databricks and actually persisted that data in a Cosmos DB and processed it through Azure Databricks to bubble it up into Power BI for their best practice report. The next step in this is going to be to proliferate this to another plant. They actually just called us 2 weeks ago, and one of their, they basically have a partnership plant. They want to do this same solution at that partnership plant, and they want to start doing their machine learning. Okay. By the way, if you guys have any questions or if I'm going too fast, please put it in the chat. Sometimes I do tend to talk a bit fast. So let's talk about cloud architecture. So the modern data warehouse sits at the heart of the enterprise analytics as a source of sanctioned data, as a system of record, and as a hub serving models for reporting, business intelligence, and data science. For this sample architecture, we are using Azure Synapse Analytics as the cloud data warehouse. Keep in mind, many of these components can be swapped out with other components and or simplified or expanded to meet your organization's specific analytic needs. As you saw in the previous two use cases, we used a very similar framework, but we did not necessarily have to use Synapse in those particular cases. So let's start on the left side with data sources. As an enterprise system of record for business processes, the data warehouse is mostly built over line of business data sources, including ERP, IoT, and CRM. Other more volatile data sources are often used for data science or for ad hoc analysis. For the data warehouse, Azure Data Factory schedules and orchestrates data transformations in bulk loads. Meanwhile, Azure Databricks performs transformations specifically for data science and also builds and executes models. Scores from these models may be loaded into the data warehouse to integrate these insights with enterprise applications and reports. Azure Data Lake may be used to store raw data in high volume for later use, along with staging transformed data from Azure Databricks. Azure Synapse Analytics provides high performance, highly scalable data storage for enterprise models with outstanding security, governance, and manageability. Power BI consumes sanctioned enterprise data from the data warehouse for reporting and analytics, but may also use data from the data lake for ad hoc analysis and integrating with data science. Many businesses, including line of business applications, consume data from the data warehouse as an authoritative, governed source of enterprise knowledge. So this is the cloud model that we've incorporated, or the framework of the cloud model that we use. Now let's talk about why we should migrate. So there's several benefits to migrating to the cloud. The first one that I'd like to discuss is performance. Scalable performance that can be increased on demand for Azure Data Factory, Azure Databricks, and Azure SQL Server, and so forth. For example, Azure Synapse Analytics, Microsoft's flagship cloud data warehouse tool, offers the best of breed relational database performance by using techniques such as massive parallel processing and automatic in-memory caching. Data warehousing is process intensive. It involves data ingestion, transforming data, cleansing data, aggregating data, integrating data, and producing data visualization and reports. The many processes involved in moving data from the original sources to a data warehouse are complex and interdependent. A single bottleneck can slow down the entire pipeline, and an unexpected spike in data volume amplifies the need for speed. Azure is a globally available, highly scalable, secure cloud platform. All Azure products reside inside the Azure ecosystem, which inherits all of the aforementioned goodness. So in a data warehouse, the demands for workload processing can fluctuate. At times, these fluctuations can vary drastically between peaks and valleys. For example, sudden spikes in sales data volume can occur during the holiday seasons. Cloud elasticity allows Azure to quickly increase and decrease its capacity according to demands with no impact to infrastructure availability, stability, performance, and security. Best of all, you only pay for your actual usage. Eliminating the overhead of data center management and operations for the data warehouse allows companies to reallocate valuable resources to where value is produced and focus on using the data warehouse to deliver the best information and insight. This lowers overall total cost of ownership and allows for better cost control over your operating expenses. The volume of data in a data warehouse typically grows as time passes and as history is collected. Azure can scale to match this growth by incrementally adding resources as data and workloads increase. Running an on-premises legacy data center is expensive. The cost of servers and hardware, networking, physical room space, electricity, cooling, and staffing are just a few of the costs. These expenses can be substantially minimized with Azure. The Azure Data Platform provides you with a true pay-as-you-go cloud scalability without the need for complicated reconfiguration as your data or workloads grow. So let's talk about some migration drivers. Businesses amass a great deal of data from many different sources and in many different forms. This gives businesses a great opportunity to discover new and transformative insights fast. However, it can be expensive and challenging to maintain the specialist skills required to produce custom applications that smoothly integrate when APIs continually change. Monitoring and managing data in production is key to catching and correcting problems early before they escalate out of control. The increased variety of data sources brings a new set of complexities to these tasks. The historical growth of on-premise applications to solve key business needs has resulted in data silos. But data silos can also exist in cloud environments through multiple SaaS applications. An enterprise integration strategy that supports on-premises and cloud helps you to deliver trusted and relevant data for transformative insights. Data security continues to challenge. As organizations evolve toward an on-premise and cloud data management model, they need to pay extra attention to securing sensitive data at rest and in motion, whether they are moving data from on-premise to cloud or from cloud to cloud. Consider a cloud data management solution that delivers data security intelligence so you can understand sensitive data risks and vulnerabilities. Migrating workloads to Azure can be a large and complex undertaking and often involves the migration of large volumes of data. This is particularly true if you're moving many different types of data, from standard relational structures and predictable batches to huge volumes, massive variety, and real-time streaming data. Having the right plan can make a huge difference in this process. And finally, market disruption requires IT to respond to business needs faster. Business decision makers have more new data types to analyze, and their analysis needs to evolve rapidly. Often this means IT must develop new processes quickly to support this. When new data sources come online, IT must quickly find a way to integrate this data, even if it is a new concept for the organization. So let's talk about some of the benefits here. So lower costs of implementation and maintenance costs. So there's really two different parts here. You have the actual implementation costs, and since many companies have SQL personnel on staff, upskilling them into Azure Data Factory, Databricks, or any of the other tool sets is a much more rapid process than you might think. The other piece here is that you only pay for what you use as far as the processing is concerned. And so you'll hear in Microsoft spaces the term compute. That's really the driver for a lot of the costs. And we're going to look at a couple of sample costs later, or actually Azure jargon, as I like to call it, and what some of those components actually look like. So you have no infrastructure to manage, and so that way you can actually reallocate those resources towards the other existing infrastructure that you have, or towards other initiatives that you might need to utilize them for. You pay for data and analytics tools only when needed, and you pause that consumption when not in use. And that includes Azure Data Factory, Azure Databricks, Synapse, any of those tools. Typically, you'll see a reduction in analytics project development time and increased innovation. You have the citizen developer kind of entering into this, where a lot of folks, if they're given access to the data sets, even if it's just curated data sets, it gives them something to start with. They are able to create a lot of their own analyses in Power BI rather quickly. We had a lot of success. Actually, our best success was with a client that I didn't mention as a use case, where we did this very, very large project of moving them from on-prem to the cloud, not only for their data warehouse, but for their ERP. And that particular individual that was in charge of project managing the ERP system also decided to take on all of the analytics. We curated the data sets for her, and she was the one that built all of the framework reports that they currently use. You also have the ability to independently scale storage from compute. And if you go into the Azure calculator, you're going to see a lot of different options that allow you to choose different ways to throttle your inputs and your outputs, your CPU, your memory. All of those are very finely tuned to what you will need capacity-wise, and also very easy then to change if necessary, either up or down. Low-cost storage for staging and production data. For instance, if you wanted to store on a separate system, you could do that into maybe a data lake, and you could put that data lake into different tiers, which would be even cheaper if you put it into cold storage, is what it's called. Most of the customers that we deal with, storage is really the lower cost of all of the other things that they're looking at. They're typically looking at transaction costs, and they're looking at compute. Avoid expensive upgrades as data volumes grow and capacity is used up by ELT processing. And this basically means is, hey, I can scale this up dynamically and scale it down dynamically as needed. I have the flexibility in the system to be able to control that. There we go. Lower storage costs as your data volumes grow. Higher levels of security and business continuity. This is very, very important, especially in the as we keep getting more and more data into all of these different systems, and more cyber criminals are out there trying to do bad things. We want to make sure that our security is there so that we can maintain business continuity. Accelerated time to insight with an analytics platform that natively integrates Apache, Spark, and SQL engines. And basically what this allows you to do is to go from thought to prototype to production fairly quickly. Most of our data warehousing initiatives are pretty rapid. I remember when I got into this particular business, data warehouses were very, very long periods of time to get implemented, and they were very complex mechanisms. We have a framework that we implement that allows us to do this really, really quickly. It's very, very dynamic and table driven, and we have some really good folks that can help you out with all of your data needs. And future-proof architecture that easily incorporates newest innovations. And what that basically means is Microsoft can and will change everything tomorrow. I'm being a little tongue-in-cheek here. If you know me, that's kind of a running joke. Microsoft's innovation is amazing, and by having what they're doing now in the cloud, yes, they do change things rapidly, but the beauty of it is you don't typically notice until you say, oh yeah, that's new, I can try that now. it doesn't really impact anything negatively. And whereas in previous versions of SQL Server, we would have different versions come out, you'd have to go through the upgrade and the compatibility. That's all pretty much evergreen, compatible now, and you don't see a whole lot of issues with any of those type of upgrades that happen pretty rapidly. All right, so let's talk about the upgrade process. We want to talk about migrating from on-prem to the cloud, and really the first thing that we want to talk about is planning. We need to plan what we're going to do and how we're going to do it. And one of the first things that I like to do is I like to assess the existing data warehouse. What do I have? What does my load profile look like? In other words, what are my row counts in my heavy tables? How do my transaction tables look? What are the different dimensions that I need to take into account? Do I have ragged hierarchies? Do I have true hierarchies? Do I have shared dimensions? I hope we have shared dimensions. That makes life a lot easier. If you don't have shared dimensions, then that's one of the first things I would go after, is consolidating those. What is the overall size of the data warehouse currently, and then try to scope that into what the ODS is going to be when you get it in the cloud. And that includes staging the data warehouse, the data mart size, the whole 9 yards there. I want to know tables and indexes if we've added indexes, so that I can really determine the true size footprint of the system. And also what's really important there is, what is the new transaction delta that happens, and what is the frequency of that new transaction delta that comes in. I need to understand data compression ratios. If I have an on-prem SQL data warehouse, chances are it's not compressed. So taking it into the cloud, it does get compressed, so we need to take those compression ratios into account. What is the current hardware configuration? How many procs do I have? How many cores per proc? What's my RAM look like? Have people been complaining about performance? Is the data warehouse itself taking now too long to process because it just has too much data and not enough horsepower to push it? So we want to try to plan for now, but also scope for the future, so that we understand how this thing is going to grow and what our processing needs are going to be in the future. Again, looking at tables, have we done any partitioning? Have we done any partitioning with analysis services? What does the whole entire data warehouse look like? Data types, views, indexes, any type of object dependencies, object usage, functions, stored procedures, and so forth. The purpose of this assessment is not just to ensure detailed understanding of the current setup across the migration team, but also to understand the strengths and weaknesses of the current setup. The outcome of an assessment of your current data warehouse, therefore, can impact your migration strategy in terms of lift and shift versus something broader. For example, if the outcome of an assessment is that your data warehouse is at an end of life, then clearly the strategy would be more of a data migration to a newly designed data warehouse on Azure versus a lift and shift approach. Next, we want to talk about a load profile. The load profile really takes all of those components that I was talking about in this previous planning bullet, and it documents it. So I'm looking at all of my big key volume tables. I'm looking at how fast are my slowly changing dimensions changing. Do I have any type of data effectivity that I need to worry about? Any of those types of business rules and conditions that I need to take into account as I'm going through this migration process. Next, latency requirements. So data latency is the time it takes for your data to become available in your database or data warehouse after an event occurs. Reporting directly against source is the best option for real-time data latency. Not all use cases require low latency data. Higher latency is acceptable for use cases that don't require real-time data. Most of the reports and analysis generated from an ODS require what is known as near-time data, which is data that is, say, an hour or more latent from the source, and many reports and analysis latency requirements are met with data from yesterday. So in other words, if you don't need to have minimum latency data in your reporting, then don't design your data warehouse in total to be minimum latency. You should be very selective with minimum latency because, quite frankly, it costs more. If you've ever tried to do real-time data with streaming analytics or any of those types of tools with Azure, you'll look at the costs and you'll realize that it is a very expensive option. And finally, we want to look at reporting requirements. Just as you are going through the exercise of determining which subject matter areas to migrate and upgrade to the ODS, performing a usage analysis of reports is an essential exercise. There may be opportunities to consolidate reports, deprecate reports, and/or create new reports pertinent to the current business environment. And another thing that you're going to have to take into account with the reporting requirements is that if you do change the underlying structure, chances are you're going to have to refactor the source data for those reports as well. So the three scenarios for upgrading your data warehouse to the cloud, the first one is lift and shift. And this is really where the existing data model is migrated unchanged to the new Azure data platform. You want to minimize the risk and the time required for migration by reducing the scope of changes to the minimum. Lift and shift is a really good strategy for legacy data warehouse environments where you have a single data mart to be migrated, or the data mart is very well designed, a star or snowflake schema, and or there is an immediate time and cost pressure to move to the modern cloud environment. You can always redesign once you get it up to the cloud if you need to do that. But if you have that need to get things up to the cloud rapidly, lift and shift is the way to go. The next one is a redesign. In scenarios where the legacy data warehouse has evolved over time, it might be essential to re-engineer to maintain the optimum performance levels or support new types of data. This could include a change of the underlying data model. The reason for a redesign approach could be due to source system structural change, business process change that has altered association data for relational or analytical reporting, additional business unit acquisition, new ERP module implementation, and a host of other reasons. And finally, there's a hybrid data upgrade, and that one can be utilized if there are certain subject matter areas that have remained structurally stable in both the source and the analytical systems. These parts of the system can be lifted into the cloud warehouse with minimal refactoring. The remaining areas can then be redesigned to suit the new business specifications. To minimize risk, it is recommended to migrate first using the lift and shift strategy and then gradually modernize the data warehouse data model on the Azure data platform using the redesign strategy. A complete change in the data model will increase risks because it will impact source to data warehouse ETL jobs, downstream data marts, and reporting. Data warehouse migration is a challenge for any company. In order to execute it well and avoid any unwelcome surprises and unplanned costs, you need to thoroughly research the challenge, mitigate risk, and plan your migration to ensure that you're as ready as possible. At a high level, your plan should cover the core data warehouse preparation, migration preparation process steps, and any tasks within them. The main process steps are pre-migration preparation, migration strategy and execution, and post-migration. I'm going to break down preparation here. So the first thing is we want to define the scope of what is to be migrated. We want to build inventory of data and processes for migration. Define data model changes, if there are any. Define source data extract mechanisms. Identify suitable Azure and third-party tools and services to be used. We've used things like Snowflake, for instance, in some cases. You want to train your staff early on the new platform, and you want to set up the Azure target platform. For a data warehouse migration to proceed smoothly, your plan should establish a clear understanding of your business case, including its drivers, business benefits, and risks. Migration team roles and responsibilities, the skill set and training required to enable successful migration, allocated budget for the complete migration, and your migration strategy. Sorry, let me go back to one more thing here. Oh yeah, I forgot this. In addition to preparing and readying your migration team for your target environment and assessing your current setup, it is equally important to also set things in motion on premises, as production data warehouses tend to be heavily controlled by IT procedures and approval processes. To avoid delays, ensure that your data center, infrastructure, and operations teams are ready for migrating your data, schema, ETL jobs, and so on to the Azure cloud. Data migration can occur via AZ copy to Azure Blob Storage, Microsoft Azure Express Route to transfer compressed data directly to Azure, and file export to Azure Data Box. The main factors influencing which of these options is selected are data volume size in terabytes and network speed in megabits per second. A calculation is needed to determine how long it would take to migrate the data via the network, considering that the data might be compressed in your data warehouse and become uncompressed when you export it. This situation can slow data transfer. All right, now we can be done. So the next step in the migration process is really a migration strategy. And with this, you want to have your goals pretty well defined. So with any strategy, there needs to be a set of objectives or goals that need to be defined to indicate success. Targets can then be set to achieve these goals and people given responsibility for reaching them. Some of the goals can include improve overall performance, data migration performance, ELT performance, data loading performance, complex query performance, and the number of concurrent users. Also, we want to run at lower cost. So cost of compute by workload, for example, standard reporting, ad hoc query, and batch ELT processing, cost of storage. Also, operate with better availability and service levels. So we have higher service level agreements and high availability, and improve productivity. So we have tasks that can be automated so that we don't necessarily have to have as much manual intervention. Next, we want to define our approach. The findings of the assessment of your existing data warehouse should significantly influence your strategy. A good assessment outcome might recommend a lift and shift strategy. A mediocre outcome due to low agility rating might indicate that simplification is needed before migration. A poor outcome might indicate a complete redesign is needed. Lift and shift leaves your architecture as is, trying to minimize the work in moving your existing system. If your existing ETL tool already supports Azure Synapse or whatever your endpoint is going to be, such as Azure SQL Server, you might be able to change the target with minimal effort. Nevertheless, there will be differences in the table types, data types, SQL functions, views, store procedure, and business logic as well. Next, we want to define our scope. Whatever strategy you choose, you should clearly define the scope of the migration, what will be migrated, and whether you will migrate incrementally or all at once. One example of incremental migration is migrating your data marts first, followed by your data warehouse. This approach would allow you to focus on high priority business areas while allowing your team to incrementally build expertise as each data mart is individually migrated before migrating the data warehouse itself. Determining what you're going to migrate. Again, you're going to look at your schema migration, your data migration, ETL processing and loading, access security and data warehouse operations, migration and visualization reports, and so forth. Next, you're going to test. The first thing you need for testing is to define a series of tests and a set of required outcomes for each test that need to be run to verify and indicate success. It is important to ensure that all aspects are tested and compared across your existing migrated systems. You'll want to automate this as much as possible, making each test repeatable and enabling a consistent approach to evaluating results. And finally, you'll want to determine what actually your success criteria is going to look like then. And what determines success usually you can tell with a series of different measures. And your highest your highest level of success criteria may be defined as a data warehouse that is accurate, fast, supportable, verifiable, usable, scalable, flexible, secure, collaborative, and provides operational success. All right. So with the migration process, you'll want to start small and simple. and you'll want to automate wherever possible. You can leverage Azure built-in tools and features to reduce the migration effort. For instance, if you're going to do a lift and shift, there is an Azure Migrate tool to help you with that. You want to migrate metadata for your tables and views, historical data that's going to be maintained. You can probably put that into like an archive folder or database, depending on how you're going to architect this. Migrate or refactor stored procedures in business processes. You'll probably have to do that with all of them. There are some differences from going to the cloud from on-prem. And then migrate or refactor ETL in ELT incremental load processes. Post-migration, you'll want to monitor and document all stages of the process. Use experience gained to build a template for future migrations. Re-engineer the data model if required. Test application and query tools. And benchmark and optimize query performance. Once you get everything up there and you start running your actual analytics and reports, that's when you might start adding some new indexes and so forth. So some design considerations, in order to reduce complexity, you want to simplify your schema if possible. One of the easiest ways to do this is to eliminate unused measure groups. Some of the very complex cubes that I see sometimes have 10, 12, 15 measure groups in there, and it gets very complex for the end user. I would recommend at that point splitting those models out. Then maybe you're going to have a little bit of redundancy, but it makes for an easier design to maintain. It makes for easier design to report against. You want to remove and archive unused tables before migrating. If you've got some data that's from a legacy system, for instance, that hasn't been used for more than, say, 5 or 10 years, and you don't report anything that goes back further than that, then you can probably deprecate that out of the system or at least archive it somewhere else. Convert physical data marts to virtual data marts. This helps to minimize what you have to migrate, reduces the total cost of ownership, and it improves the agility of your system. And you can sunset your unused reports. So we're going to go through a couple diagrams here. The first one here is migrating one data mart at a time. So as you can see, all the way under the data marts column on the almost on the right side here, the bottom mart is circled. So we'd want to migrate one data mart at a time, get the connection from the ETL process from our on-prem data warehouse to support that, and then rewire whatever BI tool we have that's coming out of that so that it consumes the data that's processed from that data mart. The next model is to take all of those models and then the data warehouse. So what we would do here is we would move all of the data marts up and rewire everything as I just described for the single data mart. And then after we get everything stable and moving the way we think it should in Azure, then we can bring the data warehouse itself up. The pros here are migrating data for data marts is still relatively low risk approach, and subsequent ETL migration is still logically separated at the different processing layers. The cons are until your migration is complete, you will have some data that exists on-prem and some that exists in Azure. That's just going to be how it happens. You're going to have a lot of duplication. And ETL processing from a data warehouse to data marts would need to bridge the firewall and be changed to target. So in this case, we would migrate both staging and warehouse and then bring the marts up after that. The pros here is that all the data warehouse historical data is migrated and therefore it's persisted in redundant storage. The cons are leaving the dependent data marts on premises is not ideal, as ETLs would have to flow data back. So you have a kind of an up and down type of a movement here. The movement from the source systems up to the cloud, and then the movement from your data warehouse down to the data marts, and then actually back up to the cloud again if you think about it if you're using Power BI. There's no real opportunity here for an incremental type of an approach as well. And then this is basically the Big Bang Theory here, where you're taking everything at once and moving it. And I would tell you that this is the most common one that we've run into, and a lot of that has to do with the fact that most of the ones that we've done have required a refactoring. So they're like, okay, I have this existing data warehouse. I've used MacGyver methods of duct tape and paper clips to keep this thing together for 10 years. I need to move the whole thing up. Okay. Something? No. All right. So ETL migration options, if you have custom 3GL code and scripts, you would want to plan to redevelop these in Azure Data Factory. You'll want to look out for a few things here. The code typically provides no metadata lineage. It's hard to maintain if the authors have gone, so you're going to have to reverse engineer it. And if staging tables are in the legacy data warehouse and SQL is used to transform data, then you'll want to resolve those changes with T-SQL. So we probably know how to do that pretty well. Stored procedures, you want to also redeploy these with Azure Data Factory. There's likely to be significant differences between legacy data warehouse and if you go to something like an Azure Synapse, or even if you're going to go to something like Databricks or some other type of transformation tool. And there's no metadata lineage there. The next one is graphical ETL, such as Informatica and Talend. With your migration options, you can use these existing tools and just switch to the Azure version of that product. You can also control the execution of the ETL services using Azure Data Factory. And you want to look out for, some of the benefits here are this avoids a redeployment and it also minimizes the risk and is quicker to migrate. And then finally, data warehouse automation software. Migration options, you continue to use your existing ETL tool. You'll just want to change the target and staging to Azure. And this, again, avoids redeployment and minimizes risk and is quicker to migrate. So a few things here, recommendations for migrating reports. Again, you'll want to do that analytics assessment, go through and do something similar, a reporting assessment. You can do parts or the whole thing with the data warehouse assessment. The analytics assessment is kind of part of it. Identify the high priority reports to migrate first. In other words, which ones are daily used, which ones are going to be needed the most rapidly, get the most spotlight on them, and so forth. Use usage statistics to identify which reports are never used, and you can probably determine if you need to get rid of them. We had one client that they said they had 600 reports, and sure enough, they did, but they only used 40 of them. Avoid migrating anything that is no longer in use. Once you have produced the list of reports to migrate, their priorities, and which unused reports to bypass, confirm this list with stakeholders. And for reports that you are migrating, identify incompatibilities early on to gauge the migration effort. So a lot of your reports, again, will need to have the data sources themselves refactored. You might not have to do a whole lot with the front end, but at least that data pipeline coming into it. So a couple things here, and I'm not going to go through, we're running out of time here, but as you go through the different features, for instance, with Azure SQL and analysis services and Synapse, you're going to see different purchasing models, deployment models, service tiers. You're going to see things like QPU and DWU. Get some education on those things, or if you get confused and you need some assistance with those, again, we'd be happy to show you kind of how that drives cost within Azure and what that means to you from a processing perspective and also from a deployment maintainability perspective. So for instance, the Azure analysis services QPU is a query processing unit. And I'll give you an example here. As a rule of thumb, one virtual core is roughly to approximate to 25 QPUs. Although the exact performance depends on the underlying hardware that you're going to be utilizing there. So you'll also want to pay attention here to the cache, because that dictates the size of the data models that you can run. Tabular cubes often run at around 10:1 compression, which means you can get about 100 gigabytes of raw data into a 10 gigabyte cube. Okay, I think we already did these. Sorry about that, I duplicated those. I meant to delete them in the other place. Are there any questions? Everybody stayed to the end, so you're either falling asleep or I said something you liked.
I think maybe more you said something you like.
I'm hoping.
So I don't have someone raised the hand. Shrihani, and I'm sorry if I'm not saying your name right. So I'm going to unmute your mic so you can ask your question. Can you please unmute your mic?
Okay, so hope you can hear me. This is
I
Yes.
can.
Harry. Excellent. I like the architecture that you shown that from ERP system data is moved to the data warehouse, but from user's point of view, when we move the data from one source to another, it requires a lot of reconciliations and it leads to time indifference. For example, if entries are processed in an ERP system, when it reaches the data warehouse, it runs through multiple batch processes, and when it reaches the data warehouse and when we report from there, already new set of entries have been posted in the source system. So
Okay.
it's makes it very difficult for the users to revalidate. We are currently facing the same challenge. We have a snowflake which is deployed on cloud. So how do we handle that scenarios?
So you're basically saying that you have updates happening to, say, the ledger or something that's causing balances to be different than what you're reporting in the data warehouse?
Right, because of the
Okay.
time difference.
Yeah. So, okay. So first off, the data warehouse should never, ever, ever be the authoritative system of record. It should be a reporting tool. Excuse me. Um, so if you are getting discrepant data, you need to ensure that your processes on whatever your system is, whether that's ERP or MES or wherever it is, that is where the source, the authoritative data comes from. If you need minimum latency for specific reports, again, you're going to go back to something like a streaming analytics or some other minimum latency type of method. You're going to have difficulty unless you're reporting directly in the ERP system. What are you using for an ERP system? Is it D365, Oracle?
Right now, Oracle, we're moving to NetSuite. So that
Okay.
the perfect world, if all your subsystems, is in ERP, then it's good. But most of the companies that have their GL in one system, then some of the subsystems are in other
Okay.
software, and that is a common scenario. And the
So,
dimensionality of these subsystems are different, and you consolidate the data, right? But for reporting, some of the software or legacy softwares and the reporting solution may not be perfect. So moving the data to a warehouse that
yep.
will help, that will help us to create beautiful reports and is easy to manage the data and things like. But that also leads to time difference and reconciliation difference.
Yeah, you have
Yeah,
reconciliation differences. Yeah.
right.
So my recommendation in that case is that you're going to have to determine the minimum latency you can get away with saying that, hey, these systems are in complete sync, and that might say, hey, it's an hour ago, or it's at noon, or something like that. We know our data is going to be completely synced up with the system as of noon today.
Right,
um,
right. But one thing I like in which you mentioned the data replication and not full data replication, incremental data replication. Like
yes.
you
Yeah.
mentioned about the Apache sparse.
Yep.
So these are like in-memory kind of adapters, right?
Yeah, and the nice thing is that you can spin up a bunch of them. That's what makes them so fast. So there's two things you're talking about here. You're talking about adding horsepower, and you're talking about incrementals.
Right.
Most of the ERP systems, well, I don't want to say most because I don't know about most of them, but the ones that I deal with are allowing for true incremental data moves from the source system out to whatever the data warehouse is going to look like, or the data mart's going to look like. And so that reduces your latency of the system down to maybe 15 minutes.
Right, right, right. So that's kind of like near real-time data that we can
Mhm.
get into the, data warehouse. But is it possible to report directly from the pipeline? So moving the data to data warehouse is an option, but instead, this Spark Apache SQLs and everything, can it query directly from the source system and create reports
You
even?
can through, I think it, what was it? It was, I mentioned it earlier. Let me go back in my slides here. Go back. Where's it at?
I think before that, I missed
Yeah.
the first few. I joined a little
Here we
late.
go. Here we go. Yeah, it's streaming analytics is what I'm looking for. Yeah, so right here, this streaming analytics, Azure Streaming Analytics will allow you to go not against every data source, but if you're going, that's going to be your fastest um, extraction piece right there, and also your most expensive.
Okay. Okay.
So that's what you would look at.
Got you. And let me clarify one thing. Another strategy we're thinking of is unifying all this ERPs into one system like SAP or something like that, or NetSuite also have multiple modules. So if everything into one module, then we can probably report from the one ERP system. But our ERP right now is not a fully integrated with other subsystems. Like, yes, we build all this staging table and everything, but it's not one product. If so, we're thinking of bringing everything into one product like a module basis and report from there. That will reduce the timing difference, and a lot of this comes with pre-built data warehouse and
Sure.
reports as well. So
Yeah,
I believe Azure is like that.
your ERP systems are definitely going to have a lot of a built-in type of framework reporting and analytics capabilities. The issue that you're going to always run into, though, if you're in a larger enterprise, is what do you do with other data? How do you mash it? How do you mash that into your other data? And so that's where the data lake and Azure Synapse really is coming into play with a lot of these larger enterprises in mashing that data together.
Yeah, in that case, a hybrid solution, but around 80% of the data comes from ERPs and maybe 20% from some third-party site and in a site and like that. Yeah,
Yeah, exactly. So,
right.
and this is kind of a very simplified model, but this is what we run into a lot. And then if you look at some of the use cases, it was also Excel spreadsheets
Yeah,
and IoT. So there were other systems coming into there. What
yeah,
this is
that's
doing, though, is it's future-proofing you for new data systems as well. You can pull those in.
right. This is what we have right now. That's the challenge we have.
Yep, yep. Understood. That's the fun. All right,
Okay. Okay, thank you. Thank you so much.
sure.
Any additional questions? Okay. All right. Well, thank you everyone for your attendance and for joining today's session. You may now disconnect.
Thank you.
Thank you.